All right, I don't have my pen with me, so I'm going to be using my mouse. Should be fun. Here we go. We're going to graph. So the first thing we got to do is graph the absolute value of x and then minus 1. So that right there means I've got the same V-shaped graph. It's going to open up because it's positive, but it starts down 1. That's the y-intercept. So it's going to start here. And if I draw my best V, it goes this way. And then it also goes this way, and it's got a slope of 1. And that's the best I can do without my pen. So let's talk about domain and range. It sounds that seems I forgot that. So the domain is the x. The domain is all the x values, and this graph goes as far left and as far right as you can possibly imagine. And so it's going to start with a parentheses in interval notation. It starts with a parentheses, and we're going to go from negative infinity, comma, all the way out to infinity, just like that, with another parentheses. Now, that actually doesn't look very good, so I'm going to make a better parentheses out there. And the range actually has a limit. So on these functions, absolute value functions, the range is where it's going to limit. And notice that the y values start, I'll do it in yellow, I'll draw this in yellow pen. It starts right there and it goes up. So the graph, the lowest part that it ever gets is a -1. So when we draw the range, we're going to do it like this. We're going to start with a hard end with a bracket like that. It's going to be, this is called interval notation, and it's the smallest value is a -1, comma, but it goes up forever, so we got that going for us. And there's your positive infinity and a parentheses on that end. So in interval notation, the hard end, oh no, that's terrible. The hard end on the left side is a bracket, and the soft end on the right is a parentheses because it goes forever. It doesn't have a stop out there. Is it a function? Yes, it passes a vertical line test. I could draw vertical lines through here, and it's called a function as long as a vertical line only touches it ever one time. It's going to be a function. So that's it. That's how you draw the domain and range on these functions, and I'm more than happy to show you other examples we can. The other two you asked about were both about standard notation, standard form. So before we do anything in standard form, I guess we need to write the equation for the line. So this graph has a y-intercept right there at -1. And if you remember, we have y equals mx plus b. Oh boy, this is fun with my mouse. That's just terrible. Plus b. I feel like a 2-year-old just got learned how to write. It's a -1, that's my b. And then I got y equals, and then I need to find m, but we're just going to count m from the graph. I don't need to do anything special with that. The slope is a negative slope. It's going downhill. That's a negative slope. And I'm going to count my rise and my run right here for you. My rise is 1, and my run is 3. There's my dogs. So my rise is 1, my run is 3, so it's up 1 over 3. Now, if I'm going to turn it into standard form, I got to do two things. I got to get x and y on the same side, and I got to have no fractions. So I'm going to go ahead and add the 1/3 x. So I'm going to try, gosh, I got to do that twice, huh? Can you just use your imagination and pretend that I wrote it over here? No, I'll write it. It's plus 1/3 x. And, oh my gosh. So what I have is 1/3 x plus y, and all that's left on the other side is equals a -1. Now, this is almost done. All we got is one more step, and that is we can't have any fractions. So in order to turn it into standard form, we got to have just x and y on the same side and a number on the other side, some constant. So we got to get rid of the fractions. So the common denominator for all the fractions, there's only one of them is a 3. So, but I have to multiply everything by a 3. And so I'm going to multiply this side here by a 3. And what that gives me is those 3's go away. I get x plus 3y equals -3. So that's in standard form there, and I'm at 4.5 minutes here, so I got to try and, let's scoot this along. So that's the equation in standard form right there, x plus 3y equals -3. Let's take a look at this last one. The first thing we need to do when we have 2 points, we got to find the slope. So let's go m equals y2 minus y1 over x2 minus x1, and I'm going to let this be y2 right there. So negative 1 minus 0, that's on top, right? There's y2, there's y1 right there. And then x2 would be right there, the negative 3. So negative 3 minus negative 1. That's a great negative sign. And two negatives there are going to become a positive, so that's a positive right there. And that gives me, on the top, it looks like I have a negative 1 minus 0, that's negative 1. And on the bottom, I have negative 3 plus 1, that's negative 2. And that's a negative over a negative, which is a positive. So right now I know my slope is 1/2. So right now what I have in slope-intercept form is this. I have y equals mx, so the m is 1/2. There's your 1/2 x. Oh my gosh. Plus b, which I don't know. So I got to find b, and I'm going to just use this point right here. I'm going to just highlight that. Gosh, I'm going to use that point right there. So x, that's going to be my y. That's going to be my x, and I still have m as a half, so I'm going to have the half. I'm going to put my equal sign, and then let's go x. X is the negative 1 right there. 1/2 times negative 1 plus b. Oh boy. And y is 0. Well, that's convenient. So I have 0 equals 1/2 times negative 1. So 0 equals 1/2 times negative 1 is negative 1/2 plus, that's the best 2 I've drawn all day, plus b. So if I'm going to add a half to both sides, and I'm not going to show the step there because it's just going to take me too long and it pains me. So b is a half. And if b is a half, that means that I have now, I'm going to go back up here, my equation is now y equals 1/2 x plus a half. That's what I have. And I'm going to take that whole equation and I'm going to multiply everything by a 2 because I want to get rid of the fractions. So what that leaves me with is, I'm going to draw it over here. I multiplied everything by 2, so on the left side I have 2y. On the right side, I just get rid of 2 fractions. So the 2's go away. I have x and plus 1. So that's all I have. And you're one step away. All I got to do is get x on the other side and I'm done. So if I take away the x, I'm done. I have a negative x plus 2y equals 1. And the only other thing you could do is sometimes we will like to say that in order to be standard form, x always has to be positive. So I could switch every single sign and I would be exactly the same equation. That would be x minus 2y equals negative 1. Either one of those would be in standard form, and if you want to practice this, I'll be happy to go over it with you tomorrow.